Welcome to the presentation video for Lab 3 Computer Organization and Architecture course. I'm Shasita Sandran from Section 1. In this presentation video, I'm going to present and demonstrate Activity 1, Exercise 2 and 3, Activity 2, Exercise 3, 4 and 6. So let's begin. This is the demonstration for Lab 3, Exercise 2. So let's begin with debug. Start without debugging. So everything is right. Now we can debug. Step over. So as you can see, we have our registers panel over here. Inside it, we have our flags. All our flags are available. And then we have our autos over here, as well as our watch, which has AL. So let's begin with F10. Our first line. Now it says move 7F hexadecimal to AL. So EAX register. So the 7F hexadecimal has been moved to EAX. And then for line 1, F10. So now 2 has been added to AL. So AX register added 2. And then we can see there are changes on the flags. So for OF, the overflow flag is OV over here, so it's 1. And then for sign flag is PL over here, so PL is 1. So for line 2 subtract 5 from AL, so register EAX is subtracted 5. Then as you can see, there are changes on the flags. So for sign flag is PL over here, so PL is 0. And then for zero flag is ZR over here, so ZR is 0. And then for the next line, move 80 hexadecimal to AL. So as you can see, the changes on the register. And then for line 3, add 80 hexadecimal to AL. So has been added the 80 hexadecimal. Then you can see there are changes on the flags. So for carry flag is CY over here, so CY is 1. And then for sign flag is PL over here, so PL is 0. And then for overflow flag is OV over here, so OV is 1. Then line 4, F10, so negate AL, so register. And then you can see the flags, the zero flag is ZR over here, so ZR is 1. And then for carry flag is CY over here, so CY is 0. And then for sign flag is PL over here, so PL is 0. And then for overflow flag OF is OV over here, so OV is 0. So that's the end of Lab 3 exercise 2. Thank you. Okay, this is the demonstration for Lab 3, Activity 1, Exercise 3. As you can see, I've already written down the assembly program instructions. Let's begin. Start without debugging. So there's no problem. F10 to execute the first line of instruction, which is to move first 2 bytes in my bytes into the DX register. Okay. As you can see, the registers are all here, the locals as well as the watch. So the first line of instruction, F10. So as you can see, the register EDX, which represents DX over here. So it contains the first 2 bytes, which is 10 and 20 over here. And then we execute the second line of instruction, which is an instruction to move the 4th byte in my words into the AL register. So the 4th byte is the 6768. So this will be moved into the AL register. So F10. So as you can see, it has been moved over here. And then we execute the third line of instruction. So it moves all 4 bytes in my bytes over here into the EAX register, all inside the my bytes. So as you can see, it has been moved to EAX register. So that's the end. Thank you. This is the demonstration for lab 3, activity 2, exercise 3. So as you can see, I've already written down the assembly code instructions for exercise 3. So let's begin with debug. Start with our debugging. So there's no problem. F10 to execute the first line of instruction. So as you can see, we already have our registers. I'm using register AX over here, so we have to refer over here, and then we have our Bluetooth as well as our watch. So let's execute the first line of instruction. Move Fiona to AX, means it will move this 90, which is in decimal, will be converted to hexadecimal and be moved to register AX. F10. As you can see, 90 decimal has been changed to hexadecimal and moved to EAX register. So we execute the second line of instruction, which is to add Fiona plus 2, means this one 95 hexadecimal to AX as well. So F10, so there's changes on the register AX, and then F10 again to execute the third line, which is Fiona plus 4, where it will move 999 hexadecimal to AX register. So it has been moved over here, and then F10 again, move Fiona plus 6, which means 9A 9B hexadecimal to AX register, and then F10 again to add Fiona 8 to AX register. So it will add this one. So that's the end of demonstration for exercise 3. Thank you. Okay, this is the demonstration for lab 3, activity 2, exercise 4. So as you can see, I have already written the assembly code instructions for question 4. So the question is to sum all the elements of array Shrek using loop instruction. So my loop here is L1, and then I've written the instruction over here. So we'll begin by clicking F10. So start without debugging. Then as you can see, the registers are already here as well as the locals and watch 1. So EAX register, after I click EAX, the EAX register now contains the value 9999, which is the first value of Shrek, and then we'll execute the second line, which is to move 7 into ECX register. So F10. So now ECX register contains number 7, and then we'll move over to the first line of the instruction, which is to add Shrek plus 4, which means the second Shrek into EAX. So F10. So now EAX register contains the value, as you can see the changes, and then after executing the second line, which is loop L1, it will go back to the first line of instruction, and then ECX now contains 6, and then it will continue to do so. So then the process continues until ECX is 0. So you can see the changes in the value of the registers. So now ECX is 0, and the value of EAX after the sum of all the elements in the array Shrek, decimal value is 79,992, and the hexadecimal value is 13878 hexadecimal. That's the end of the demonstration. Thank you. Okay, this is the demonstration for laboratory 3, activity 2 exercise 6. As you can see, I've already pasted here the template of question 6. So if we go through the code, we can see EAX has the value of 0, and then the value of counter has been moved to ECX register, which is 7, and then in a loop it will add 10 hexadecimal to EAX until the loop becomes 0. So let's begin with start without debugging. Okay, so there's no problem. F10. So now we have registers over here as well as watch. We have EAX, ECX as well as total. So when we execute the line, move 0 to EAX, EAX value has been changed to 0 as well as you can see it over here. And then F10 again, the value of counter, which is 7, has been moved to register ECX. So now in the loop, add 10 hexadecimal to EAX register. So 10 hexadecimal has been added to EAX register and the decimal value can be seen over here. And then loop will decrement the value of ECX to 6, as you can see over here, and this will continue until the loop or ECX becomes 0, while the value of in the EAX register will be added by 10 hexadecimal. So this continues. So when the value of ECX becomes 0, the value in the EAX register will be passed to total. So now the total in value is 112, and in hexadecimal the EAX register 70 will be passed to total. So that's the end of the demonstration. Thank you. This is my overall reflection for Lab 3, Computer Organization and Architecture. In carrying out this Lab 3, I was able to further understand the concepts of offset pointer (PTR), direct indirect addressing as well as looping. The lab activities were quite challenging and allow me to think critically in order to complete the task. The reference videos and notes provided prior to Lab 3 is useful for me to understand the task better. Therefore, in total, Lab 3 has further enhanced my knowledge about the assembly language code. Thank you.